Here out with another math video, and for this video I'm actually starting a new series called Road to Grade 11 University Math, which we deal with all of the things that go in university math, or at least the things that you need to know in university grade 11 math. So if you're just preparing for grade 11 math, or you're here because your teacher didn't know how to explain something to you properly, or you didn't understand what they were saying, well, I am here to fix your problem. So, let's get on with the video. For grade 11 math, the first thing we're going to be talking about is relations and functions. Now, you may be wondering, what is a relation? Well, a relation is a set of ordered pairs of corresponding independent and dependent values. And when we say ordered pairs, we mean a point, or points in this case. And we say independent, we mean x, which we always mean x when we say independent, and dependent, we mean y, which we always mean y when we say dependent. Remember that it's all the way back from grade 9 or below. So, an example of a relation is this. So when x is 0, y would be 0, so this is a point. When x is 1, y would be 1, so that's another point, and so on and so on. So you're probably thinking to yourself, so does that mean all lines, or like all lines are actually a relation? Yes, all lines are a relation. And this line looks very familiar. It's actually the equation y equals mx plus b. And this will pop up quite a bit in grade 11. You'll still be using y equals mx plus b, but not as much as you'll be using probably parabolas and other things like that. And a line doesn't only have to be parabola or something like this. It could also be something jumbled up like this. So when the value of x is 0, the value of y would be 1. When the value of x would be 1, the value of y would be 4. The value of x would be 2, the value of y would be 5, and the value of x would be 2, the value of y would be 2. So what would this look like? It would look like this actually. So we can see here that when x is 0, y is 1. And when x is 2, y is also 2. When x is 1, y is 4. And when x is 2 again, y is 5. And you'll be actually seeing this maybe quite often. Depends if your teacher likes putting these types of lines instead of these types, or parabolas, whatever. But this, just remember, this is also a line, and just ignore the different colors. And since it's also a line, it means it's also a relation. Now, you may be wondering, since we saw in the title function, you might be wondering, what does the word function mean? Well, a function, well, it's for every x value, there's only one corresponding y value. If the x value has another corresponding y value, so if the corresponding y value is 2, then it is not a function. So an example of this would be, as we see here, for the x value of 0, there's only one corresponding y value when it comes to the x value of 0, which is 0. For the x value of 1, there is 1. For x value of 2, there's 2. X value of 3, there is 3. So each one of these only has one corresponding y value. But if you have something like this, which has 2 corresponding y values, so since this is 2, it's connected to both 5 and the y value of 2, then that is not a function, because it has 2 y values. So the same x value cannot have 2 different y values if it is a function. So just telling you that right now. Now, how do you determine if a relation is a function? And by the way, just for you to know, a function is always a relation, but a relation is not always a function. So, for an example here, let's go back and let's see. This would not be a function because it has 2 y's that correspond to one x. And since it's not a function, a relation is not always function. Because sometimes functions don't exist, but relations, when it comes to lines, always exist. So, let's find out a way to determine if a relation is a function. So, to know, we would have to look at the ordered pairs, and if you see an x value that corresponds with two y values, it's not a function, as we already went through when I was telling you how to tell if it's a function or not. So, like I said here, this would be a function since all the x values only has one corresponding y value. But here we can see that we have one x value that corresponds to two y values, which means it's not a function. Which means this relation is not a function when it comes to these points. Now, what's the other way to tell? Well, if you don't have values like in a table that tell you that, what's another way how I can tell by just looking at a graph? Well, it's something called vertical line test. And in a vertical line test, the vertical line intersects a graph in at most one point. This shows that there is only one x value for every one y value. So if I look here, here's our graphs. And let's say we didn't have these tables to tell us that these graphs were a function or not. Then we could tell just by putting a line straight down, and I mean straight down, in certain points. Like for this line, if we put a line straight down here, we can tell that it's a function because there's only one y value that corresponds with one x value, which is here, in this point. But if we do it here, we can see that the part that we covered up with our line actually has 2 points. Unlike this part that only had 1, this part has 2 points. Which means that this isn't a function since the line covered more than 1 point. Now, to cover up some of the other terminology we need to know, like what's a domain and what's a range. Well, a domain is all the possible values that x can be and all the possible values that y can be. So if we look back, to our graphs here, for this line that goes infinitely, by the way, we can see that there are multiple x values, which are 1, 2, 3, 4, 5, and keeps going for infinite amounts. But if you have a line like this one that has only a couple of x values, then you would have to say the number of x values. And the same thing goes for the y values. It's all the possible y values that can be in a line. And sometimes lines won't go for infinity, but some lines will and some lines won't. And we'll actually cover what you'll do if we have lines that cover infinity and what lines don't go to infinity. And if you have any questions about any of these, please comment in the comment section. Please subscribe for more videos to come out. It really helps and it shows your support to my channel. Please get other people to subscribe to me too and watch my videos so that they can also have help. I hope that I've been helpful, and remember, please tell me if you need help in the comment section, or if I didn't explain something correctly or you didn't understand me, so I can properly explain it. Hope this helped you in all the ways possible. Have a great day and have a great everything. See you guys.